Hi, it's Adam here, and today we're going to be going over the ROT-13 cipher that we made yesterday and just trying to make it a little bit more robust, a little bit more cohesive, and hopefully by the end of this we'll be able to deal with more complex strings that include spaces and capital letters, and we'll have a ROT-13 cipher that is more true to its name, able to perform all of the functions that a ROT-13 cipher is intended to perform. Now, keep in mind this is not a ROT-47 cipher, and the difference between those two is that the ROT-47 cipher is able to handle special characters, numbers, things like that, whereas the ROT-13 cipher is just letters. And then today we're going to make it able to handle spaces as well. So where we left off yesterday is we have this lambda function that takes in our input string and then runs it through this algorithm. Now what this algorithm does is it checks the index of each letter in the input string and checks the index of in the alphabet for that letter. So H is the 0, 1, 2, 3, 4, 5, 6, 7th index, and then it would add 13 to that, so then it would get the 20th index, and whatever that number is, in this case for H it's 20, it would divide that by 26 and take the remainder. So since 20 is less than 26, whenever you divide by 26 you get 0 with a remainder of 20, and so in this case our index would be unchanged. Now if we were to take let's see, L is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th index, and that also would be unchanged because if we had 13 it would be 24. So let's take O, which O is the 11, 12, 13, 14th index. So if we were to add 13 to that, we would get 27. And then if we divide by 26, we get 1, and there's 1 left over. So our result is 1, so we're trying to find the AZ index of 1. That's what this resolves to. So the AZ index of 1 is B. So the ROT-13 cipher, when taking O as an input, will result in B. And so that's what this lambda function here does, and it does it for each letter in X, and X is just whatever we pass in to the lambda function. So code of some string, in this case X is hello, X world, X how, X are you today. And if we were to run this code, see where we are. I think I can just run it from here. Oh, sorry. Need to run Python 3. So here is our encoded string. This is hello X world blah 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 encoded, and now I can take this, add it back in, run the file again, and you can see we get hello world, how are you today, with X's in between to signify the spaces. So today what I want to do is I want to go through and make it so that we don't have to put X's here to indicate spaces, and instead we can actually have the spaces. So first I'm going to get rid of this lambda function. We are going to create that's not what I intended. There we go. We're going to create a function called ROT, and we're going to pass a string into here. And we also need to take this and put it down here. Now, if you don't know how I'm doing all of this with the keyboard, this is what the Vim extension does in VS Code. It allows me, let's get this out of here, it allows me to run Vim commands in VS Code. So that's what's going on here. Okay. So first first we are going to need a list called words, and in here we are going to store our string, but we're gonna split it at the spaces. So string.split at the space is going to split up whatever string we pass into here on each space, and then store each word as an index value in words, in this list called words. And then we're going to create a different list. We're going to go ahead and call this final, and that's going to be our final result after running this algorithm. And now for letter and x, we no longer have an x value, so we're going to do for letter and string, because that's the string that we're going to be passing in to this function. And let's see, what else do we need? Okay, yeah, we need to return final code is equal to space dot join final, and we're going to return final code. Now I think that this will work, except we're not using final code equals, oh yeah, but wait, code equals dot join, forgetting my for statement, for word in words. So we're going to iterate through each of the words that we have in our words list up here. You know, we split our original string into words, and now for each word in that words list, we're going to create a code of each of these words, and we are going to append that code to the final word list. And then we're going to take the final word list, we're going to join it all together using a space, and that's going to be our final code string, and then we're going to return the final code string. So now we can just pass into ROT our final string, and I think this will work. Yep, so we get hello world, how are you today, with X's. But now let's do it without any spaces. Hello world, how are you today? Or sorry, let's do it with spaces without any X's. Ooh, okay, so what do we do here? Words equals string dot split. Let's see what our words list looks like. Hello world, how are you today? Okay, that's what I wanted. For word in, oh yeah, this is what we're doing wrong here. So I'm gonna change this word, make it word. Okay, so what happened here, why we were getting the whole string all at once, is that in our list comprehension here, we were saying for letter in word, in string, and string was the whole string, but we needed to break up the strings, and we needed to break up the string into words, and now we're saying for each individual word in words, then for each individual word in words, go through that word one letter at a time, take the index of that letter, add 13 to it, divide by 20, take the remainder, and then we're going to do that for each letter in the word if the letter is alpha. And actually we don't need this anymore, because since we're just doing a ROT-13 cipher, we're going to assume that everything is going to be alpha. So let's try this again. There we go. Now we get our encoded string with the spaces intact. Now it is all lowercase, so we can do something really simple to make sure we can handle any case. So az.indexLetter.lower. So basically here we are just going to take whatever our letter is, if it's a capital letter or a lowercase letter, we're going to lowercase it and then find the index of that in this list of our letters of our alphabet, which happens to be lowercase letters. So now I can say hello world, how are you today? And we'll get the same results here. Yeah. And let's pass this through. This is our encoded message. So this isn't what I want. This is our encoded message. So now we can decode it and we should see hello world, how are you today? It will all be lowercase though. What did I mess up? There we go. Hello world, how are you today? So that's it for today's video. I wanted to keep it short and sweet. Just get some practice in on making these videos, really. Learn how to talk into the microphone. This is my second ever time doing that after yesterday. And also to help make this ROT-13 cipher a bit more cohesive, something that's a bit more usable and has more use cases. So now basically any string of letters that you could possibly think of. Let's see. Let's do something that Caesar would have actually said. Maybe the enemy is not prepared for our attack. Attack at once and notify me of results. Okay, so now we can encode that. Whoa, what did we get wrong here? Substring not found. Oh, we can't do periods because this is not a ROT-47 cipher. All right, so here we go. This is our encoded message. This is what it would have looked like whenever you received an encoded message from Caesar. Actually, he used a different coding algorithm that we're gonna look at sometimes in the future, which typically was a shift of 3 letters to the right, which means that you need to use a different algorithm to decode from the algorithm that you use to encode. So we'll look at that here shortly, but this is what an encoded message using the ROT-13 cipher would look like. Yeah, you can see here we got attack and attack. They're the exact same thing. So that's what I got. Thanks for watching, and I will see you in tomorrow's video.